Hello, everyone. It's Mr. Kissinger at the Citizenship Academy in Syracuse, New York. And this is 5th grade math, Module 6, Lesson 8. We're going to generate a number pattern from a given rule and plot the points. So we're going to kind of put everything together here that we've been doing the last couple of lessons, and we're going to be making lines based on rules. So let's look at number 1. It says complete this table such that each y coordinate is 4 more than the corresponding x coordinate. So our formula here, or our rule, is y equals x plus 4. So we need to make a couple points that will follow that rule. And we can choose anything for our x values as long as our x values are on this grid. So I'm going to start with 2 as an x value. Maybe we'll pick 5. And let's do 8. So 2, 5, and 8. Our y value will be 2 more than our x values, or 4 more than our x values. So if we have x plus 2, we have 2, or 2 plus 4. We have 6 as a y value there. 5 plus 4 will give us 9. And 8 plus 4 will give us 12. So our coordinate pairs, 2, 6, 5, 9, 8, 12. And let's plot these on our coordinate plane. So we have 2, 6, 5, 9, right here between 8 and 10. And we had 8, 12. 8, 12 right here. We're going to use a straight edge to draw that line. My ruler here. Now it asks us to give the coordinates of another 2 points that fall on this line with an x coordinates greater than 18. So now let's do 20 as an x coordinate. 20 plus 4 would give us 24. And then if our x value was, let's say it was 32, our y value would be 36. Then we just add 4 to it, and that will give us any point on that line. Number 2 says complete this table such that each y coordinate is 2 times as much as its corresponding x coordinate. So again, we can pick any number that's on this grid here, as long as their corresponding y coordinate is not going to be greater than 12. They don't want to be way off the grid paper here. So 6 would give us 12 because if our x value is 6 and we multiply by 2, that would give us 12. That would put us right at the top of our grid paper here. So let's do our last x value is 6. That'll be 6, 12. And then maybe we do 0, because 0 will be, for multiplying, well, 0, we know our line's going to run right through our origin through 0, 0. 0 times 2 is 0. And then let's do one right in the middle. Let's do 4. And 4 times 2 is 8. That'll give us a ordered pair of 4, 8. So we have 0, 0. We have 4, 8. And we have 6, 12. We can draw a line right through all three of those. And then we need to do two other points that fall on this line with a y-coordinate greater than 25. So our y-coordinate is going to be greater than 25. Our x-coordinate is going to be half of our y-coordinate. So I have to choose x values that are going to be more than half of 25, or I can just start with my y-coordinate that's greater than 25, and I could divide by 2 to get my x-coordinate, because division is the inverse of multiplication. So let's do it that way. Let's do 26 as our first one. So if our y value is 26, our x value will be half that, which will be 13. Our x value times 2, 13 times 2 would give us 26. And then for our second one, let's do 50 as our y value, because we can easily cut that in half and make it 25. All right, let's look at our next page here. Use the coordinate plane below to complete the following tasks. Graph these lines on the plane. So it says line L, x is equal to y. So whatever x is, y will be the same thing. So we could do 0, 0, which would be 0, 0 as an ordered pair, 5, 5, or we could do 10, 10. Keep it nice and simple. So we have 0, 0, 5, 5, 10, 10. And we can draw a line right through. We'll do our grid. It's going to split our grid like right in half diagonally. And this is going to be line L. Line M, y is 1 less than x. So we have x. Let's make x equals 1, y equals 0. X equals 9, y equals 8, and x equals 15, y equals 14. 8, 15, 14. You know what? We were supposed to label these first 3 points here. So this is going to be A, this is B, and this is C. And then we have 1, 0, which is right here, 9, and 8. So we have 5, 6, 7, 8. And we have 15, 14 right here. These two lines are going to run parallel. These will never cross. This is line M. And these are points G, H, and I. And finally, we have y is 1 less than twice x. So that one's going to be kind of tough. So that one's going to be y equals 2x minus 1. 1 less than twice x. So let's put an x value in here. Let's just do 1 as our x value. We'll start down here again. And if we do 2 times 1 would be 2. Minus 1 would give us 1. This will be 1, 1. And then 2, we can do, let's do 3 as our x value. 3 times 2 is 6, minus 1 is 5. And then if we do 5, 5 times 2 is 10, minus 1 is 9. So 3, 5, and 5, 9. So we're going to have 1, 1, which is right here. And then we have 3, 5, 5, 9. This will be S, T, you get a little busy here at the bottom. This is line N. All right, and then do any of these lines intersect? If yes, identify which ones and give the coordinates of their intersection. These ones that intersect under, like, beyond the grid here, but the only ones that intersect on the grid are going to be lines N and line L, right here at this point S. Line S, or line N, and line L intersect at 1, 1. That follows both of those rules for those lines, so those two are going to intersect. Are any of these lines parallel? The line M and line L are parallel. This is give the rule for another line that would be parallel to the lines you listed in problem 3C. So in this line here, I would say that any line that was plus or minus, just had a plus or a minus in it, and nothing else, will be parallel to those lines. So we could do a line like y equals x plus 1 would be an example. Because if it was x plus 1, we could do 0, 1, 1, 2, 2, 3, and it would go right here, just a little bit above line L there, whereas M would be a little bit below because that one's minus 1. So anytime we're just adding or subtracting a single digit like that, I think those lines would be parallel. So x plus 1 would be an example of one such line. So we're going to wrap up there for today. Thank you guys so much for tuning in, and look forward to seeing you next time.